The cube function has the formula f of x is equal to x cubed. So we're going to make a table of values in order to graph this. So just like with the previous two functions we've looked at, we are always in charge of x. So I'm going to go ahead and pick the same x values I've been using. So -3 all the way to +3. Okay, we always want to pick a variety of x values. You want to pick something positive, something negative, and also 0 in the case you don't know what your graph looks like. So then we're going to take each x value and we're going to plug into the formula, which is f of x is equal to x cubed. Remember, f of x is the same thing as y, so we're going to have y equals x cubed. But remember, if you're doing x cubed, that just means you're taking x and you're multiplying it by itself 3 times. So it's x times x times x. Okay? All right, so we're going to take each x value, plug it into the formula to get the corresponding y value. That will give us an ordered pair, x, y, that we can plot. Let's start with x equals -3. So if x is equal to -3, that means the y value is going to be, we're going to take the x value, -3, that entire quantity is going to be cubed. That just means you're taking -3 and you're multiplying it by itself 3 times. Okay, so it's going to be -3 times -3 times -3. Okay, so if we simplify here, -3 times -3 is +9 times -3 is going to give us -27. So that means the point that we would plot on the graph is going to be -3, -27. Okay, so if x is -3, the y value is going to be -27. Okay, moving on to x equals -2. Okay, the y value will be the quantity -2 cubed. That means -2 times -2 times -2. If we simplify, -2 times -2 is +4 times -2 is going to give us -8. So if x is -2, y is -8. Okay, moving on to x equals -1. Okay, we're going to take -1, the x value, and we're going to cube it to get the y value. Okay, so this means nothing more than -1 times -1 times -1. If we simplify, -1 times -1 is +1 times -1 will give us -1. So you will see if x equals -1, the y value is also -1. So -1, -1 will be a point on the graph. Moving on to x equals 0. We're going to get y equals 0 cubed. That's 0 times 0 times 0, which is 0. Okay, so this graph is going to go through the origin. Most of these basic functions go through the origin. Okay, now we get to our positive x values. Okay, so we'll start with x equals 1. So the y value will be 1 cubed. That is just 1 times 1 times 1, which is 1. So the graph will go through the point 1, 1. All right, couple more. So if x is equal to +2, the y value is going to be 2 cubed. That is just 2 times 2 times 2. So 2 times 2 is 4, times 2 is 8. So if x is 2, y is 8. And then lastly, we'll do 3, x equals 3. We'll get that y is equal to 3 cubed. That is just 3 times 3 times 3. 3 times 3 is 9, times 3 is 27. So if the x value is 3, that means the y value is 27. Okay, so we have several xy pairs to plot to graph this function. Okay, I will start at the top here. The first point is -3, -27. Notice that the y value is -27. That's going to be off the grid. Okay, so yeah, it works, x equals -3, we can find that, but the y value would be way down here if you can see where my cursor is. So that point is on the graph. It's just not going to fit on the grid that I provided. So we're going to skip plotting that point. Okay, we're going to start with -2, -8 because it will actually fit on our grid. So -2, -8 is right here. Okay, and then we'll plot -1, -1, and then the origin, and then 1, 1, and then 2, 8 is right here. And then when you get to 327, again, we can find x equals 3, but our y values on this grid only go up to 10. So 327 is going to be way up here off the grid, so we're not going to bother plotting it. Okay, so now we just need to connect the dots. What x cubed is going to look like is an S shape. It is a long S. Okay, so if I connect the dots here, it's going to look like this. Okay, so in this direction, it's going to go up forever. So we're going to put an arrowhead to indicate that it goes up in this direction forever. And then in this direction, it's going to go down forever. Okay, so that is the graph of x cubed. Again, it is a long vertical S. In a couple of minutes, we are going to graph the function f of x is equal to the cubed root of x. Notice they are not the same. This is the cube function, x cubed. This is not the cubed root function. The cubed root function is going to be the cubed root of x. Okay, that's what that's going to look like. It's going to be a similar graph in that it's going to be an S shape, but it's going to be a horizontal S. Okay, so you need to keep these two graphs straight. Okay, the x cubed graph is going to be the long vertical S like this. Okay, all right, so before we move on, let's write down the domain and the range of f of x is equal to x cubed. Okay, domain, we have lots of options. Okay, let's think about our table of values. Okay, we could plug in anything we wanted for x. We could plug in 0. We could plug in positive numbers. We could plug in negative numbers. Nothing got us in trouble. Okay, you can also look at the formula. Okay, x cubed is a polynomial. Okay, so this is telling us that the domain is all real numbers. Okay, now let's take a look at the range. Okay, so we're looking at our y values here. When you write down the range, remember you want to go from the low point to the high point. Okay, so since, if you look where my cursor is, since in this direction the graph goes down, 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 down forever, the lowest y value is going to be negative infinity. Okay, and then in the other direction, the graph goes up, 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 up forever. So the highest y value is going to be positive infinity. Okay, so for the function f of x is equal to x cubed, both the domain and the range is all real numbers. All right, let's move on to the next basic function. All right, the next one is going to be the absolute value function. It is f of x is equal to the absolute value of x. So if you take a look at this, you see this notation, you see these two vertical bars that I've just highlighted in yellow. That is just indicating absolute value when you see those vertical bars. So this is the absolute value of x. Okay, so let's talk about what absolute value is. You've probably seen it before, but you may not remember what it is. So in a nutshell, what absolute value is, absolute value turns everything positive. Okay, so I'm going to write that here. Absolute value turns everything positive. That's what you need to remember. Okay, so like if you have a negative number, okay, and you take the absolute value of that negative number, the absolute value is going to turn that number positive. If you have instead a positive number and you take the absolute value of the positive number, the number is going to stay positive. Okay, also if you have the absolute value of 0, it is going to be 0. Okay, so what you need to remember, like I said, important here to remember, absolute value just turns everything positive. Okay, it turns negative numbers positive, it keeps positive numbers positive. All right, so we're going to graph this function out by making a table of values. Again, I'm going to pick my standard x values that I've been picking. Okay, we're going to take each x value and plug into the function. Okay, we've got f of x is equal to the absolute value of x. That's the same thing as y equals the absolute value of x. Okay, all right, so let's start making our table. Okay, all right, if the x value is -3, we're just going to plug it in. Go to your formula, everywhere you see x, replace it with -3. So we're going to get y equals the absolute value of -3. Okay, so you are taking the absolute value of a negative number. So the absolute value is just going to turn it positive. The absolute value of -3 is +3. So the point you're going to plot is if x is -3, the output is going to be +3. Okay, that's how this works. So we just keep doing this. So now if x is -2, that means the y value is going to be the absolute value of -2. Okay, the absolute value of -2 is going to be +2. Okay, the absolute value just turns the number positive. So if x is -2, the y value will be +2. Moving on to x equals -1. The y value is going to be the absolute value of -1. Okay, the absolute value of -1 is +1. So if x is -1, the y value is +1. Okay, moving on to x equals 0. Okay, the y value is going to be the absolute value of 0. The absolute value of 0 is 0. Okay, so this graph also goes through the origin. All right, moving down to positive x values. Okay, so if x is +1, the y value is going to be the absolute value of 1. Okay, the absolute value of a positive number is the number itself. So the absolute value of 1 is 1. So if x is 1, the y value is 1. So the graph will go through the point 1, 1. Moving on to x equals 2. That means the y value will be the absolute value of 2, which is 2. So the graph will go through 2, 2. And then the last one I'll do here is x equals 3. So the corresponding y value will be the absolute value of 3, which is just 3. So if x is 3, y is 3. Okay, so we have several points to plot, so we'll get a good idea of what this graph looks like. So I'm just going to start plotting points. We've got -3, 3, -2, 2, -1, 1, the origin, 1, 1, 2, 2, 3, 3, and so on. Okay, so what this graph actually looks like, it is a V shape. Okay, so what I'm going to do here is I am going to draw a line here. Okay, so if I look to the left of the origin, this is what's going to happen. Okay, the graph's going to come down as a line through these points to the left of the origin. Okay, what's going to happen at the origin, we're going to get a sharp corner. Okay, so I'm going to write that down. There's going to be a sharp corner at the origin. Okay, because you have to make that V shape. Okay, and then once you get to the origin and you go to the right through those points, okay, it will just do this. Okay, so the graph will go on like this. Okay, so you get that V shape. Okay, the graph goes up in this direction forever and it goes up in this direction forever, so you need arrowheads. Okay, so you really need that sharp corner at the origin so you can see the V shape. You need to remember this. Okay, if you're dealing with the absolute value function, think of the V in value. The graph is a V shape. Okay, so remember value V. Okay, that's how you can remember this. All right, let's talk domain and range now that we have the picture. Okay, so domain. Okay, if we think about the table, nothing got us in trouble. Okay, because remember with domain, we're thinking about what x values we're allowed to plug in here. Okay, we could plug in 0, no problem. We could plug in positive numbers, no problem. We could plug in negative numbers, no problem. We could plug in anything you want. Okay, now as far as the formula goes, we haven't talked about absolute value at all in this class up until now. Absolute value is not considered a polynomial. Okay, so we really don't have any basis, for judging the domain from the formula. If you look at the graph though, the graph keeps going in this direction forever. So kind of like the leftmost x value is going to be -infinity. And then the graph also goes in this direction forever. So the rightmost x value is going to be +infinity. So the domain here, however you want to look at it, whether from the graph or the table of values, any x value will do here. Okay, and that makes sense. Think about what the function does. Okay, if you plug in an x value, no matter how crazy that x value is, all the absolute value function does to it is turn it positive. Okay, so you can really plug in any x value you want. The domain here is all real numbers. Okay, range, let's look at the y values. We need to go from the lowest point on the graph to the highest point on the graph and write down the y value. Okay, when we look at the lowest point on the graph here, the lowest point here is the origin. Okay, so the origin has a y value of 0. Okay, this is a closed circle, so we do want to include y equals 0 in the range. Y equals 0 is the output when the input is x equals 0. Okay, so then we need to go off to the high point. Okay, again, in either direction, the graph goes up, 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 up forever. So the highest y value is essentially positive infinity. Okay, so the range of the absolute value function is going to be from 0 to infinity, including 0.